Hi everyone, this is Keshav Agarwal and today we are going to discuss LeetCode daily challenge, that is concatenation of consecutive binary numbers. So in this question basically we are given with the number n, and what we need to do is we need to calculate the binary representation of a number from 1 to n, and we need to concatenate all of this binary representation, and then the final number we need to find the decimal value of that final number, and we need to return modulo times per 9 plus 7 of that value, right? So for an example, let's say n is equal to 3. So the three numbers are 1, 2, and 3, right? So the binary representation of 1 is 1, 2 is 1, 0, and 3 is 1. We need to concatenate this number, right? So it will be 1, 1, 0, 1. Need to concatenate these three numbers, right? So the in the binary representation, the number is this one, right? Binary representation. So what will be the decimal representation of decimal value is 16 plus 8 plus 2 plus 1, that is 27. And what we need to do is we need to calculate the mod of it, the 27 mod times 9 plus 7, right? That is 27. So our final answer will be 27, right? So the one thing we can do is basically uh, from 1 to n, we calculate their binary representation, convert them into string, concatenate that string, and at the end we calculate the final value of that string basically. This is one way. Or the another way is basically, if you can see from here what we are doing. Can I write this number as something like 3 plus 2 into 4 and 1 into 16? Can I write this number something like that? So what basically happened is 3 came directly as it is. Now the number of bits in 3 is basically 2. Number of bits in the binary representation of 3 is 2. What does that mean? The number that came just up before 3 is left shifted by the number of bits that are there in the 3 itself. So for example, number of bit in 3 is 2. So 2, we are left shifting 2 by 2 number. And if we shift a number, if we left shift a number by x, so basically we are multiplying that number by 2 to the power x, right? So if we left shift a number, let's say we left shift 1 by 2, what does that mean? We are multiplying 1 with 4, and 4 is nothing but just 2 to the power 2. So if we left shift a number by x, we are just multiplying that number by x. So if we shift y by, if we left shift y by x, we are not doing nothing but we are multiplying y by power of 2 commas, because what we are doing, let's suppose the number is 1 0. Now we are left shifting them. So left shifting means if we left shift this number by 1, right? So what does that mean? We are multiplying this number by 2. If we left shift this number by 2, we are multiplying this number by 4. So if we left shift y by x, it means the final number will be y into 2 to the power x, right? So this is what happened with 2 basically. We are left shifting this 2 by the number of bits that are there in the 3, in the binary representation of 3. So we are left shifting 2 by 2, that is 2 to the power 2, that is 4, right? And the number of bits in 2 and 3 combined are 4. So we are left shifting 1 by 4, right? So I can write it as a 1 into power of 2 to the power 4 plus 2 into power of 2 to the power 2 plus 3 into power of 2 to the power 0. Because we haven't shifted 3 by any number, we have shifted 2 by, we have left shifted 2 by 2, right? And we have left shifted 1 by 4. So what we need to do is basically we will traverse this number and from n to 1, right? and we will calculate the number of bits in the given number I, so that we have total number of bits, so that we can calculate. Uh, so let's suppose we are 1, 3, 4, I, and we need to do till n, right? Now let's suppose I am currently at ith number, right? So let's suppose x is the number of bits from I plus 1 to n. So the contribution of I will be I into power of 2 to the x, right? I hope it makes sense to you. And just we need to do this summation over all I, right? So what we are doing is, suppose const int more is 129 plus 7 and int number initially 0. We need to traverse from n to 1, and at the end we need to return the number, right? So let's make a number bit. What we will do is basically give me a number. Bit is basically how much time I want to multiply the current I. So for an example, I have multiplied this 2 by 4, right? And I have multiplied this 1 by this 4 into 4. 4 into 4, right? So I need to find the number of bits in the I. So let's make a function. Number of bits in X basically. Y, this is basically to calculate the number of bits. Right. And what we are doing is from bit number of bit in I. Now we need to this one count bit. So what we are doing basically, for 3 my bit will be 1. For 2 my bit should be 4 because I need to multiply this 2 by 4. Right. Now for 1 I need not to calculate the contribution that made by, let's suppose, 4 and 5. 3, 4 and 5. I know how much I multiplied. Let's suppose I multiplied 2 by x. Now I need to multiply 1 by x into 2 to the power y, where y is the number of bits in 2, right? I need not to calculate this x every time, because if it is shifting the 2 by 2 number, the 3 is also shifting 1 by 2 number, but the difference is 1 is shifted by 2 more number because of this 2. That is why I'm calculating this power of 2. So to calculate the power of, let's suppose this is y, so I need to calculate power of 2 to the power y, right? And that can be calculated by 1. Right, shift 1 by y, right? And I will multiply this by 8. Let's see, not here because I need to do in calculation only. And it might do as well also. We need to take this module as well. I hope you are getting that. So, like, to 3, we are just multiplying 3 by 1. Now, for 2, we are multiplying this 2 by 4. And now we know, let's suppose 2 is multiplied by x. So, so 1 will be multiplied by x into number of bits. Let's say y is the number of bits in this 2. So we need to multiply x by into power of 2 to the power 1, where y is the number of bit in 2. Right? And we need not to calculate x because we have already. That is y. And I'm going to run this y by bit by 2 to the power 1. So let's see. And yeah, so that's it. Okay, thanks for watching.